This is the VSQG Compliance Guide by Echelon Environmental. And we're on to lesson number 3, independent requirements for VSQGs. Now this is a big one, it's complicated, I'll go through it, and who knows, you might have to watch this a couple of times in order to really grasp what they're talking about, unless of course you're already very familiar with the regulations. So, we begin. Very small quantity generators, VSQGs, as you know that I love to call them, are the lowest category of hazardous waste generators, meaning that they really have the fewest number of regulations. There are so few requirements that it's actually almost kind of funny. But of any of the generator categories, we'll talk about them later, the VSQGs have the easiest row to hoe. Okay, it's good. Being a VSQG is actually good, I mean, because you're saving money on waste disposal and because there are so few requirements that you have to follow. Remember that for each generator category, there are now independent requirements and conditions for exemption. I mean, we go through that a number of times, but this is one of the biggest changes that they've made in this regulations. This kind of stuff didn't exist before. So these are all of the independent requirements for VSQGs. Okay, independent requirement number 1, make a hazardous waste determination, HWD, for each waste generated at your facility. So each waste that your facility generates must be subjected to an accurate hazardous waste determination. This is the most important step in the entire waste management process because it's just where everything begins. So, what you need to do is make a list of all the wastes at your facility and do a hazardous waste determination for each of them. The hazardous waste determination must be made at the point of generation and prior to any mixing, dilution, or treatment. Okay, so what they're saying is they want you to look at the raw waste that's coming out of whatever process you're generating before anything else happens to it. So that's actually a really important consideration when you're evaluating the hazards of a waste and how to characterize them. The solid waste determination is not discussed here. 99% of your wastes are solid wastes and therefore potentially hazardous wastes. Now, the solid waste determination is one of EPA's most convoluted discussions because in order to be hazardous, in order to be considered a hazardous waste, it must be a solid waste first. But there are lots of ways out of the solid waste characterization. So we're just going to assume that all of your wastes are solid wastes. If you believe you have a waste that is not a solid waste, I recommend you make darn sure of your conclusion, because if you're not handling it as hazardous, and it is, you could get in big trouble. The steps for the hazardous waste determination are: 1. Determine if the waste is excluded from regulation under 40 CFR, whoops, I spelled it wrong, 40 CFR 261.4. That's a section in the Waste Management Standards. This section specifies many wastes that are completely exempt from being considered hazardous wastes. There are more than 40 types of waste that are specifically excluded from being hazardous waste, including domestic sewage, pulping liquors, shredded circuit boards being recycled, used cathode ray tubes, etc. They go on and on and on. Now, if your solid waste, if the waste that you're looking at is among those 40, that's actually good because then it isn't a hazardous waste. All of the requirements for managing of it go away. Well, not all of them, but it just makes it a whole lot simpler. So 2, if the waste is not excluded, then you must determine if it is a listed waste. and I will do my best to try to explain what a listed waste is. So listed wastes are those that meet the definitions in subpart D of 40 CFR 261. Okay, now I hate to get into the regulese kind of talking here, but sometimes that's the only option I have. So listed wastes are those that meet this definition in subpart D, and it's rather complicated, and we're going to briefly cover it here because it could go on and on. The listed wastes come in 4 different categories, okay? There are the F list, which are generally described as non-specific spent solvents. There's the K list, which are wastes from specific processes. There's the U list, which are toxic chemicals that are unused. And there's the P list, which are acutely toxic chemicals that are unused. So those are the lists. If we talk about listed wastes and you have an F listed waste, K, U, or P listed, then these are listed wastes. The application of the codes in this section is by definition, which is an odd concept to get in your head if you haven't been dealing with it for a really long time. If the waste meets the definition, the code applies. Okay, it doesn't matter what kind of concentration. It doesn't matter the physical state sometimes. It's just the definition, and we'll go through one of them here. So here's the definition for F008, plating bath residues from the bottom of plating baths from electroplating operations where cyanides are used in the process. That's an exact quote. That is the definition for FU8, as we call it. Okay, plating bath residues, blah, blah, blah. So if you have a plating bath residue where there's no cyanides that are used, okay, it's not FU8. It has to meet this definition exactly. So there. That's kind of how these listed wastes work. So making this decision requires detailed knowledge of the waste constituents and how the waste was produced. Okay, so 3, if the waste is not listed, okay, if you've gone through all the potential lists and try to figure out where your waste may land up and it just doesn't meet any of those definitions, well, that's good. Okay, so then you take the next step, which is if the waste is not listed, then you must determine if it is a characteristic waste under what they call the D list. So now you have listed wastes and you have characteristic wastes. So this is done by comparing the properties and constituents to the lists in subpart C of 40 CFR 261. So you can see that the listed wastes were by definition. The characteristic wastes are based on the relative properties of the hazardous constituents, let's say. So there's a big difference between the two. The D list is by far the most commonly used waste numbers for characterizing hazardous wastes because they are the most general. The first 3 codes on this list, we're going to go through all of them briefly here. The first 3 codes, do 1, do 2, and do 3, that's how we call them. I hate saying D001. Okay, describe physical characteristics of a particular waste. Do 1 are for ignitable wastes. So the do 1 waste code applies to flammable liquids, which have a flash point of less than 140 degrees Fahrenheit, to flammable solids, and that's a complicated discussion right there, and to oxidizers, which are chemicals that like to make other stuff catch on fire. So the bottom line is this waste code, do 1, covers a wide range of ignitable wastes. And that's it. If it applies, if you have a flammable liquid and the flash point is less than 140, this waste code applies. Do 2 are for corrosive wastes. Now, the corrosive wastes are all based on pH. Acidic liquids, okay, with a pH of less than 2 are considered corrosive waste by EPA, and they get the due to waste code. Alkaline liquids with a pH of greater than 12.5 are also corrosive liquids. They get the due to waste code. Due 3 are for reactive wastes, and there's a whole range of different types of reactive wastes out there. So you've got water reactives, organic peroxides, pyrophorics, which are fun because those are chemicals that automatically, spontaneously burst into flames when they come into contact with air. And of course, explosives, those are also pretty reactive. So the next 8 waste codes, due 4 through due 11, are for metal-bearing toxic wastes. And these are pretty important because they're very common. So here they are. Due 4 for arsenic, due 5 for barium, due 6 for cadmium, due 7 for chrome, due 8 for lead, due 9 for mercury, due 10 for selenium, and due 11 for silver. I have an acronym that I use to remember all these, but I'm not going to go through that because some people get offended by it. So these are the codes for toxic metals, okay? And so when we talk about heavy metals in the EPA world, these are the 8 metals that we're talking about. All the other metals, hey, they can be toxic too, but these are the ones that get waste codes, and so we pay more attention to them. The rest of the codes, due 12 through due 43, okay, so the due codes go due 1 through due 43, are for organic chemical toxic wastes. And there's a whole bunch of them. Okay, I'm not going to go through the whole list, but it includes such yummies as chlordane, chloroform, MEK, pyridine, tetrachloroethylene, and trichloroethylene, and a whole bunch of other ones. So the important point about the D list is that it's all about the numbers. Each code is based upon a numerical regulatory level. That's how you'll hear them referred to in discussion all the time. So you saw that with due 1 and due 2, the waste code is applied based on a numerical standard, flash point, and pH. With the toxic wastes in the D list, it's the same. And hey, how about an example? So we're talking about, we have in this table here the contaminant, the regulatory level, and the associated waste number. So arsenic, the regulatory level is 5 milligrams per liter, and if you have a solution or a solid, that's hard to explain, but let's just say that if your waste has more than 5 milligrams per liter of arsenic, it gets the due for code. So do you see that? If it's above that regulatory level, it gets the code. So for chloroform, it's 6 milligrams per liter, and that waste code is due 22. For lead, it's 5 milligrams per liter, and that gets the waste code due 8. So like for lead, if you have a waste and it only has 3.5 milligrams per liter, okay, that's below the regulatory level, the waste code does not apply. It's not a hazardous waste. So for lindane, 0.4 milligrams, 2,4,5-T, a good old-fashioned chemical, 400 milligrams per liter. So you can see a big range in the different regulatory levels. So this is the story of how the D-list waste codes are applied. Okay, step 4. If, at the end of this long process, there are no EPA waste codes that can be applied to your waste, then it is not an EPA-regulated hazardous waste. And that's a good thing. The properties and constituents of any waste can be determined by 2 different things: generator knowledge and analytical test results. The waste code doesn't matter when you're doing a hazardous waste determination. You use 2 different methods to come up with the information to make the determination: generator knowledge of the waste and analytical test results of the waste. Or you can use a combination of both. So based upon the knowledge or test results, the properties or content of the waste is compared to the regulatory levels to determine if the waste is hazardous. Any waste that is hazardous is assigned an EPA waste number. Okay, that's a really important fundamental thing. If you have a hazardous waste, there must be an EPA waste number assigned to it. Again, the lists, FU1 through FU39 for the F list, all the different K list numbers, all the different U lists, 411 of them. For the P list, there's only 205. Isn't that nice? And for the D list, there's only the 43 of them, do 1 through 43. These waste numbers are very important as they follow the waste everywhere it goes. But VSQGs don't need to use them. Isn't that interesting? After going through all this to determine if your waste is hazardous as a VSQG, you don't need to use the waste numbers. Well, that's the way they got it set up. So at this point, you have complied with most of the requirements for a very small quantity generator. You could skip straight to determining your generator category and be done with it. But you have already gathered the information you need to do 3 more things that the big boys, those small quantity generators and the large quantity generators, have to do. 1 is to see if your hazardous waste can fall under the regulation of other sections of the rules and fall out of the hazardous waste status. 2, document your hazardous waste determination. And 3, identify all of the waste codes that apply to the waste. My stand here is that you should do these 3 things even though you don't have to. Why? Because first, someday you might become a small quantity generator or a large quantity generator, and this would be a good warm-up for being ready to step up into a higher level of regulation. And because if you're ever inspected and you show them that you've gone the extra step and done these 3 things, they'll see that you're way ahead of the game. This will show them that you're serious about managing your waste. Chances are that they will go in search of softer targets elsewhere, thinking to themselves, well, this guy's got everything all wrapped up, so we're not going to bother with him. I mean, that's literally what they do, okay? Sorry, that's the way it is. And, by the way, these things are easy to do. So if you want to impress the inspectors, which is always a good idea, then do these things. Okay, here we go. We got through it. So, lesson 3, quick review here. The hazardous waste determination. Vital step. Really important you get that right for all of your different wastes. So for action steps, let's find your wastes wherever they are throughout the facility. You're going to have to look. You believe me, if you've never gone through your facility and checked for all the different kinds of wastes, you'll be surprised. And then do the hazardous waste determination for each of those wastes. Lesson 4 coming up, we're talking about voluntary compliance with some of the rules. Okay, so we're going to take the next step in the next lesson. Okay, congratulations, you're on the way. Compliance is the combination of knowledge and action. You can do it. This is Ron Harvey, signing off.